Okay, who loves React? Who is working with React? Who is working and doesn't love React? Okay. And who loves performance? Who hates performance? Okay. So I think you're going to enjoy the next talk. The next speaker has a strong experience. Okay, this time it's working. The next speaker has a strong experience from front-end, back-end, and so on. He seems young, but he has lots of years of experience. I read in your bio. And he also loves playing piano.
Yeah, a little bit.
So it's time for Assaf.
So hello, I'm very excited to be here. This is my talk. React is killing your performance and it's your fault. So about me, I'm from Tel Aviv. I'm a co-founder of Lifecycle, which is a seed stage startup we founded about a year ago. We create live ephemeral environment created automatically from every commit in your source code. And we use those ephemeral environments to enable collaborations across the team. So not only we provide a link with a live environment for every code change, we also enable rich collaboration features inside, like taking a screenshots, pointing on something and talking about it. So everyone on the team, including non-developers, can discuss alongside the product, on the product, and while developing it. So check it out. It's very cool, I think. And I love React. I love also fast user interfaces. I share a deep love for both of those things. So that's what we're going to talk about. The slides are on my GitHub. Sorry if it's not very readable, but and I have a Twitter account. It's not very active. I'm mostly a lurker over there, but you can check it out if you want. So this is the first part out of three. Let's talk about the dangers of declarativeness. All right, so as I mentioned before, this talk is primarily about performance with React. So a subjective truth, number one out of two, is that no one likes leggy UIs. Certainly, I don't like them. We would like our user inputs to be reflected as fast as possible in our applications, so we get the feeling that it all happens in real time. We get that effect. If we lose that effect, we lose our concentration, we lose track of what we do, and we are less happy in life. And one other thing worth mentioning is it's not only about feelings. It's like if you're a company and you're building UIs, many studies with Google and Yahoo and other companies shown that when the performance decreases, users leave your application, their engagement is reduced, and churn is introduced, which is a bad thing for your business. Another subjective truth is that everybody loves the native-like experience, right? And by native-like experience, I mean applications that are stateful, that they have complex UI inside them, panes, model windows, tabs, and so on. And the browser was originally designed to show very static pages, you know, text, very slow loading images, and maybe a form, but that's it, which honestly was great back in the day, but today we're expecting fully complex application. We have VS Code running in the browser, we have full operation. It's like an operation system. And I think it's great. I would like every application on my computer to be on the browser. I love that experience. But it's kind of hard to do with the native browser APIs. So we have fast and responsive UIs. We have native-like user experience. Combining that creates awesome web applications. That's what we want to get. But how do we achieve that? So let's talk about declarative UI frameworks like React, like Svelte, like Vue, like Angular, and all of these. And they're very popular. And the reason for that is, again, it's very hard to create those experiences without them, right? So what is declarativeness in that context? Because HTML and CSS are already declarative. With HTML, you describe the way components have relationship with one another, parent-child relationship. You have event handlers to deal with stuff that input, like user inputs happens and stuff like that. With CSS, it's declarative in the sense that you describe the style of your application using selectors and stuff, and you just tell the browser how to stylize your application given a certain set of rules. But in our context, we're talking about state-driven declarativeness. So meaning that we want to have our app behave in a certain way when certain state changes. And that's kind of hard to do with just HTML, CSS, and JS. So we're using framework. So let's see a simple example to illustrate that. We have a button over here, and internally there's some kind of a state. And the state is just counting my clicks, right? And that state is being represented on this component here, the paragraph component. I'm just showing the number of clicks. And I added a very cool feature. Whenever the count is even, I'm showing this message. And when it's odd, I'm removing that. So how would we have implemented this quite simple thing using imperative programming with only native JS? So we would have to create the elements and append the attributes inside them. We'd also have to create the state. And after doing all of that, we need to handle our user events. So on click, I'm not only updating the state, I also need to bind that state into the inner text so I can show what's going on. Also, there's some logic here. If the count is even, I show that confetti message. If it's not, I need to remove that. And it's all pretty complicated for a very simple thing. As a programmer, I don't want to deal with that. I just want to deal with the business logic of what does this button do in a declarative way. This whole thing is not only increasing the amount of code I need to write, it also introduces potential bugs because I might forget doing stuff, like removing event handlers, which can cause memory leaks, or just forgetting doing stuff. And when your app is getting bigger and bigger, it really becomes a nightmare doing it like so. So we're using a thing like React to declaratively program this. So it's, as we can see, it's very clean. You basically, all you have is, in a declarative way, you tell React, I want to take this state and use it in this way, right? And automatically, whenever this is updated over here, the entire thing reruns and it gets updated. So this is like a kind of magic, right? It's not clear how it works just by looking at this. So let's have a very simplistic overview of the reconciliation algorithm, which is what React is using internally to provide this declarativeness. So let's say the DOM is looking like this right now. It already has the div parent element, which contains the paragraph and the button and the message count is even. It's even because the count is 0. Right? So what React does is creating a replica of that DOM called the VDOM, which is kind of a bad name because it also can run outside of the DOM, like native apps and VR application and crazy stuff like that. But we'll use the name VDOM. And the VDOM is basically a replica of the DOM with added features like it can hold a state, right? Now, whenever I update the state using my event handler, which is doing set count as we saw in the example, now the React is getting triggered again with the updated state, which is now 1. Now, React is running that render function again and recreates the internal elements of the VDOM. And it notices the stuff is changing. Specifically, what changed in this example is the count in the message was updated, and we removed that message. So React is keeping that in mind, so it can translate those into DOM operations in the case of a DOM, or native apps, native operation, or other stuff as well. So that's basically what happens, but the important thing I want to take from that is this is the DOM after the applied diff. So it all happens at runtime, right? So it means the CPU is doing stuff to make it happen, and it's doing it while the user is interacting with the application. So it has an impact. And usually that impact is very small, but it can be accumulated and be added up into something that might be actually damaging the performance of your application at some cases, right? So I want to quote Rich Harris, he is the author of Svelte and a very, very brilliant individual. And he's saying the danger of defaulting to doing unnecessary work, even if that work is trivial, is that your app will eventually succumb to death by 1,000 cuts, with no clear bottleneck to aim at once it's time to optimize. So death by 1,000 cuts basically means if you get 1 or 2 cuts, it will be fine, but it can add up, which will cause death. So let's talk about avoiding death and how to overcome those issues. So probably you're not going to die. And probably when optimizing stuff, it's too soon, and you're just being paranoid, because we all make this problem. We all have these problems as engineers. We want to do things right, and we want to make them as fast as possible. But really, most of the time, like 95% of the time, we don't really need to do that. The app is working fine. It's just our paranoia kicking in. So we have this relevant XKCD here. Usually we are doing premature optimization. We really want to avoid that because it's unnecessary work, it's add complexity into our applications. And one thing that happens a lot with React is, to me, it happens all the time. When we're developing, we have React runs in dev mode. And it's doing that so it can have like warning messages and warn us about stuff we might be doing wrong, and this causes quite a bit of overhead, and it's getting rid of it production mode. So first, maybe check if you're in dev mode if you encounter performance issues. So an example here, I have, I hope it's visible on the screen here. I have like a thing that responds to my mouse drag events, and it just randomly draw points on the chart on the right here. And I'm using this lag meter created by Dan Abramov in one of his talks to demonstrate that it's quite a bit laggy because this thing is rapidly changing and it's changing a lot of elements. But this presentation is actually running in dev mode. And let me get to that slide. This is the production mode of the same presentation. So what I wanted to show is that in production, it's actually, I don't know if you can see that on the projector, it actually feels way nicer and smoother because it's doing like maybe half of the work it's doing in dev mode. Right, so let's talk about cases where you are going to die. Basically, you tested, you saw that your performance is not that great, you tested on all sorts of devices, you need to improve that. So what can we do to improve performance? Basically, our first strategy would be avoiding unnecessary renders so that React won't have that overhead we talked about. So how do we do that? So one of the basic methods is using react.memo. Basically, if your component is pure, which means that given the same state and the same props, it returns the same thing. Basically, it doesn't have side effects. You can wrap it around with an HOC. An HOC is higher order component. It's a function that gets a component and returns a new one with added functionality inside. So if you wrap it with that, React will avoid rendering again. It's kind of relevant to the previous talk where we talked about immutable data structures, because React is doing that by comparing shallowly the props property. So we can actually use record and tuples for that. But let's see an example for that. So this is an example that I have an input field here. I type stuff. It's very slow. It's annoying. I'm getting angry. Because it has a component here that's artificially doing slow stuff. You can imagine in a real application, this might be a very complex thing like a big chart or a map with lots of elements inside. And I also wrote here, it's an indicator of how many renders this slow component is making. So you see every time I type a letter, it re-renders it. But the thing is that it shouldn't be doing that because it doesn't depend on the state of this input field. So basically the code is like this. We have an input field. We change the input to reflect the state of what I wrote. And alongside it is the slow component. So what we might notice is this slow component doesn't depend on props or state. It doesn't doing any side effect. Basically, it's a pure component. We can just wrap it around the memo, and React will avoid re-rendering it by comparing the previous prop, which is nothing, with nothing. It's always, it will never re-render, basically. So now when I type, I see the render counter stays the same, and my leg meter is happy and green. Right, so another thing we can do is we can separate it into different components. So in the previous example, the slow component didn't have any dependencies. It wasn't dependent on the state of what I was typing. There is no need for me to couple it with the state. It's better to separate the state and keep it as close as possible to the element that's using it. Basically, lowering down the tree of elements instead of keeping it up. The more it's down in the tree, the less things are going to be updated. So in this case, all I need to do is taking this thing with this thing, moving it outside like this, and then wrapping both of those things together. Now, I'm not going to re-render the slow component ever because nothing is changing here. It's only changing inside the input component. So it doesn't only give us better performance, it also better separation of concerns, and your code is a little bit cleaner. So it's better doing it like this. Also, another thing we can do is separating wrappers using the children prop. Again, it also reduces render calls while making your components a bit more general purpose. So what I mean by that is, again, I have this slow component. Now I have a button that changes the color of this frame. And this is, it's not nice. I click on it and it takes a while for it to render it. It's annoying. So how can we improve that? Again, we see that this thing doesn't really use this state. We should separate those. So we can do that by using the children prop. And now I can wrap the slow component using that general purpose color border. And now my app is behaving very nicely. Another thing we can do is, at some pretty rare cases, we might want to consider stepping outside of the reconciliation loop. Meaning React's declarativeness doesn't, it really holds us down in some cases. Specifically, maybe it's more suited for libraries which renders complex graphics like D3 or charts libraries and so on, because stuff are changing rapidly by events, maybe drag events or typing events, and things are changing a lot in your application. React will hold us down in those in this case. So Let's see this example again. Again, this is changing very rapidly every time I drag my mouse across the screen. And basically what it does is it generates random data every time I drag my mouse. And it uses this data to draw my chart. So this happens maybe 60 times per second or something, on this screen even more. So we can't really avoid render calls. We can't use our previous methods because the app itself is actually changing every frame. So this is a pure unnecessary overhead in this case. We can step outside of the reconciliation, out of the declarative world, back into the imperative world to apply those state changes ourselves. We can do that, for example, by using the ref. Ref is a way for providing us with the reference to the internal DOM element, the actual DOM element, not the VDOM element. And then we use the draw function on every draw to imperatively change the X and Y attributes of those SVG elements to change their positions on the screen. So this is with reconciliation, this is without. It maybe will increase the number of points to better demonstrate that. So this is very, very slow. This is a bit better. Not that great, but way better, maybe twice as much. Right, so let's talk about embracing death. So let's talk about cases in which there's really nothing left to do. Your app is slow. You just have you've written a software that is too complex for your CPU to handle. And it's more rare, but cases like this exist, where you want to present something which is very complex, maybe a huge chart of points, or a map with lots of location markers and stuff like that, that is changing rapidly, maybe due to events and stuff like that. You want to have this illustration, but you also want to have your UI respond fast and not get your UI get stuck. So again, sometimes you can't avoid renders, and is there anything we can do to improve that? So let's go a little bit back for a second and talk about how did we get to this point anyway, because all of the optimization methods I discussed earlier are a consequence of how React chose to implement declarativeness. But actually, it doesn't have to be this way. There are two basic approaches to implementing this kind of stuff, right? React reconciliation is pull-based. Every time something changes, React recalculates the entire tree. But another way is doing it the other way around, push-based updates. Basically, components can subscribe to state changes and re-render them accordingly, just the state that they're using, not the entire state of the app. Another name for this is called reactive. And it's kind of ironic because React is not really reactive. It's kind of, but not really. And so reactive programming is a way to declarative subscribe to events, state changes basically, and act accordingly. So the most famous example of that is probably Excel or any other reactive spreadsheet, where you define some sort of a function in one cell, and then it depends on other cells, and when you change one of those other cells, the function automatically changes as well. So it reacts to other state changes. Another example is Mobix, which is also the author of Emer, which was mentioned in the previous talk, and RxJS, which is reactive extensions, which is basically an observable library that you can subscribe to a stream of events and do stuff accordingly. There are also UI frameworks like React, which work that way. For example, Svelte and Solid, what they do is at compile time, they have a compiler, and they inject those reactive behavior according to only the state that a specific component uses, instead of React choice, which is the opposite. So why did React choose it? So I have a quote here from Sebastian. I'm not going to pronounce his last name because I don't want to mispronounce it, but he's one of the core members of React and one of the architects of the algorithm. And he's saying here, and it was a while ago, it was 7 years ago, using the other approach, which is more about scheduling, as he says, has its benefits. You can plan and prioritize your work. So what does he mean by that? Using the pool-based approach, you can harness the scheduling for powerful tools. So since React 16, which was, I believe, maybe 5 years ago, they rewrote the entire reconciliation algorithm to enable such features. So basically, it allows asynchronous rendering of the VDOM. So what does it mean? This is, again, a very, very simplistic explanation of the algorithm, just to make the point. So now, if we have the VDOM we showed earlier, this is for the example of the chart with the dots. Let's say you have all of those circles, those n circles with their locations, x, y, y1. If we change it, now what can happen with React Fiber is that we can actually pause rendering and resume to it later. And doing so will allow us to step outside of reconciliation and spread it across several frames, not in the old ways. You have to do everything synchronously. You can't step outside of it. It only happens until it's done, even if it's take a very long time. So now you can pause it. And you can either resume if you have time and nothing changed, or you can throw that away. And you can throw it away in cases where the state you used to draw the new update has changed. For example, when I drag my mouse to create the points, I then redrag them, the points changed. I don't need to use the work I started doing because it changed again. It's garbage now. I can throw that away and restart. So React 18, fresh out of the box, last month or so it came out, and it gave us new hooks to harness that power to create a very nice user experience. So we can now separate between high priority state updates and low priority ones. So I'm going to show what that means. And we're doing it by using either the start transition, we also have use transition, or use deferred value. Those are hooks to allow us to paint state changes as low priority ones. So let's return to that example. Now we have the imperative and declarative like before. Let's increase the number of points so it can be more visible. So declarative is really bad. Imperative is a little bit better, but they both really suck because it's annoying. It's frustrating. I want this thing to react to my mouse. Otherwise, that feeling of interaction with the computer is getting lost. But using the use deferred value hook, it allows me to, I hope it's visible on the screen, it allows me to set the dragging of the skull to be higher priority than the updating of the dots. So you can see those dots on the right, they are updated every other frame instead of every frame. And instead, it renders the movement of the skull on every frame. So very quickly, I'm going to show how it's implemented. So this is the previous version. Now we can take the data, which is the state, which is basically a list of random points, and we can mark it as we can ask React to give us a deferred version of that state, meaning it can be a little bit lagging behind. And we use the deferred data to draw the points while using the actual data to update the skull position. One caveat of this is we have to use memo, otherwise React will just re-render everything. So we have to use memo to draw the actual points. You can also do it with the other hook, which is transition. Start transition is more for wrapping around the actual setter, and use deferred value is for the actual data, the actual value. So this is in cases where you have access to the setter. This can be done also if your data is passed from your parent component and you don't have access to the setter. So yeah, these are the differences between them. One is for data and the other one is for setter. Just a quick note, you can actually achieve this kind of behavior using debounce or throttle, but this is better because with React React Fiber, it doesn't run on every time it updates, as opposed to debounce or throttle, which always happens. It happens only when it needs to. So it's a scheduling algorithm. It asks the scheduler, do I have more time? If so, I continue the work. Otherwise, I pause the work. So even if your computer is fast, you'll get the very good, everything renders every frame. If your device is maybe slower, maybe mobile device, you'll get the more debounced feeling. So in summary, React Runtime has an overhead. Most of the times, you don't need to worry about it. If you do, try to avoid render calls, or let it go of declarativeness is another way, and use deferred value or start transition to prioritize parts of your UI when nothing else helps. That's it. Thank you.
Thank you, Assaf. Is there any question in the room? Is there any question from Hopin?
So in order to achieve heavy tasks in rendering or data management, WebAssembly would be a choice in order to integrate it in our React. So I'm guessing the question is about using WebAssembly to improve performance. Again, which is, yeah, a case of that. I mean, one of the best things you can do to improve performance is just write more performant code, which I didn't really address. I addressed more of what to do when you can't have a better performance. My point of view came out of the fact that you already try to improve the performance, but yeah, you can use sometimes WebAssembly to improve performance for sure.
Okay, thank you. I have a question. What framework, what UI framework do you suggest on start building an app?
Right, so when starting, probably maybe React is not the best choice for starting something. I would choose it for more complex UIs. It's kind of have a rough start to it. I started looking into Svelte lately, which is very nice for maybe simpler stuff because the community is not as big and you have less of an ecosystem, but it's really nice to build simple and high-performant UIs. Maybe in the future it will also be more suitable to bigger projects, but I haven't tried.
Okay, thank you. If no question, no. Okay, so thank you, Assaf.
Thank you.